Electrical circuits can often be intricate, like the one you see here. It can include many components, many devices, like here we have 13 resistors and a battery, so that's 14 devices altogether, with lots of wires connecting them, and then so many different ways the components are connected to each other. However, what's good is, no matter how complex the circuit is, we can easily determine which two components, whether they are resistors or capacitors or any other two-pronged electrical device, battery, inductor, anything. As long as it has two prongs, we can very easily determine whether those two components are in parallel or in series. Knowing whether they are in parallel or in series will help us simplify the circuit by replacing these devices by their equivalent. And when we do that, it will help us analyze the circuit much more easier. Okay, let's start with the rule for series circuits. How do we determine if two components are in series? Actually, here are two rules in one statement. The first rule, and I'm writing it here for capacitors, but even though the graphic has resistors, the same rule applies for any device, so it does not matter. So capacitors C1 and C2 are in series if and only if every loop that contains C1, every loop that I can draw in the circuit that contains C1 also contains C2. The other way we can check is to follow one wire from one capacitor to the other with no branches in between. What we mean by branches is something like this or like this. It's like whenever the charges are going to have more than one path they can choose from. That's a branching. So I have 3 paths that they can choose from. Here I have 2 paths that they can choose from. That's a branch. Okay, now every loop, these loops we are talking about, are loops that we can draw. Okay, let me do a quick thing with the highlighter right now, just to demonstrate what we mean by a loop. It's basically arbitrarily, if you are going to determine, if you are going to check a particular resistor, you come next to that resistor and start drawing a loop. You know, for example, this is one loop that I was able to draw that includes R6. Okay, let me draw another loop at another color. For example, this is also a loop that includes R6. Let's do a third one. This is a loop that includes R6. Okay. These are examples of loops that include R6. Now, what they tell us here, let me remove these loops. What they tell us here, if and only if every loop that contains one of the components, whether it is a capacitor, resistor, or whatever, also contains the other one. Every loop that I can draw in the circuit should contain both of them. Let's check R12 and R6, for example. Okay, so I'm going to do that by drawing a loop that has R12 and R6. I actually prepared that, so that's one loop that I drew that contains R2 and R6. It contains also R3, R4, R8, R13, and the battery. Okay? Now let's see if every loop is going to contain both R12 and R6. Now this loop has R12, but it does not have R6. It has R12, R11, R13, and the battery, but not R6. So that tells me that R12 and R6 are not in series. Now let's go back and look at the same loop we had earlier, but let's check if R12 is in series with R13. Now in this case, we see them both in the same loop. They are also in this same loop, R12, R11, R13, and the battery. Okay, let's try another one. Okay, this one has R12, R6, R2, R1, R4, R8, and R13, and the battery. And actually, I can go through every possible loop that I can draw here, and all of them are going to include R12 and R13. Then I can conclude that R12 and R13 are in series. Now, the other test works a little differently. What I need to do is, starting at the resistor, for example, here I'm going to try to compare R12 and R6. Starting from one of the resistors, I'm trying to go to the other one. Can I find a path with no branching? So if I try to go this way, there is a branching. I cannot do it. If I try to go the other way around, and there is a branch. So that's not going to work for R12 and R6. However, okay, let me erase what I just drew. However, if I'm going to try to compare R12 and R13, if I try to go this way, there is branching. That does not work. However, if I go this way, I was able to get to R13 without any branching. It does not matter that I have a battery in between. It does not matter if I had another resistor or a capacitor or whatever in between, as long as I can find a path without branching to go from one to the other. So both of these are actually in series. The two tests allowed us to check that out. Okay, let's look at the test for parallel. The parallel test is a little different. It says if and only if you can make a loop that has only C1 and C2 and nothing else. So we need to find a loop that has both of them and nothing else. For example, here I have 3 resistors. So it's not a loop that has just the 2 of them. Same thing here, R5, R4, and R3. However, this loop includes R11 and R10. So that tells me that R11 and R10 are in parallel. Okay, same thing. Actually, I'm missing one. Let me draw it by hand. Let's look at R6 and R7. Perfect. We found a loop that includes both of them.